Okay, everyone. I thought we would take a couple minutes to practice a couple mass stoichiometry problems. So if you have your mass worksheet out, I'm going to be looking at question 3 and question 4 on the worksheet. So you may want to have your sheet out and you can follow along. All right, let's start with number 3. Now, it's going to be important that every time you start a stoichiometry problem that you have the correctly balanced chemical equation. So when we read through the reaction given on the sheet, it tells us that sulfur trioxide, which is a gas, it's going to be reacting with water, which we know is a liquid, and it's going to be producing sulfuric acid, and acids are always solutions. So we want to make sure we have the equation written correctly, and then we want to make sure that it is balanced. So if we take a peek, we've got 1s on both sides, 3 oxygens plus 1 is 4, and we have 4 here, and 2 here, and then 2 here. So our mole ratio from the balanced equation is 1 to 1 to 1. So sometimes it can be helpful also to write that down. When we read through the question, it tells us that we're looking to calculate the mass of sulfur trioxide, which is this, if we're going to produce 1,000 grams of our sulfuric acid. So we're going to have to convert our grams to moles, because remember, the balanced equation tells us the mole relationship between the reactant and product. And then to get our answer back in grams at the end, we're going to have to convert. So for this particular problem, I'm going to use the 3-step method. So in step number 1, we're going to take the 1,000 grams of the sulfuric acid, and we're going to have to convert that to moles. Now, use your molar mass sheet that you have to get 98.08 grams per mole. And then if we calculate that out, we're going to get 10.20, oops, I'm going to write the wrong unit, moles of sulfuric acid. All right, now that we've converted to moles, our next step is going to be the mole ratio. So another thing that can be helpful, we're focusing on this, and our mole ratio is 1 to 1. So we're going to take our 10.20 moles of sulfuric acid. Notice I'm writing not only the unit of mole, but I'm writing the substance. And we know from our balanced equation, for every 1 mole of the sulfuric acid, we started with 1 mole of the sulfur trioxide. So this is allowing us to go from the moles of the sulfuric acid to the moles of the sulfur dioxide. And you may be thinking, oh, I don't know why I have to write this out because it's just 1 to 1. Well, you have to show your work. You have to show the conversion from one substance to the next. Now, for the last step, I'm going to take the moles of SO3, which I just solved for in step 2, and I'm going to convert that to grams. So the molar mass of sulfur is 32. And I'm going to have to add that to the molar mass of oxygen, which is 16 times 3, to get 1 mole of SO3 is 80.00 grams of SO3. When I do out the math, I'm going to get 816 grams of SO3. Now, when I look at the answer sheet, the answer does say 817. It's a little bit off, probably just because of slight rounding. But remember, the last digit here is always estimated anyway, so that would be an acceptable answer. So 3 steps, just to review. In step 1, you're going to take the grams of the substance given and you're going to convert to moles. In step 2, this is where the stoichiometry piece comes in. You're going to convert from moles of substance that you're given to the moles of substance that you're looking for. And in the third step, we're going to take the moles and convert back to grams. Now remember, you can do this out in 3 individual steps, or you can combine these steps into one long step. So that's the method I'm going to use for number 4, because I know some of you want to be working towards doing that one step. All right, so when we look at number 4, again, the first thing we need to do is read the question and write out the balanced equation. What mass of carbon dioxide will be produced from the complete combustion of 64 grams of methane? All right, so methane is CH4. When a hydrocarbon reacts, it has to have oxygen as a reactant. The complete combustion tells you we're making carbon dioxide gas and water. Now, because this is an exothermic reaction, that water is going to be gaseous. Now, we want to make sure the reaction is balanced, so we'll need a 2 here to balance our hydrogens, which leaves us with 4 oxygens, so we'll need a 2 here. Again, may be helpful for us to write down the mole ratio is 1 to 2 to 1 to 2. And when we look at what we're going to be focusing on, we're focusing on the methane, which is this one, and the carbon dioxide, which is this one. So we have another 1 to 1 ratio. Now, when we do this in one step, we're still going to follow those 3 steps that we looked at, but we're just going to put them in one T-chart. So we're going to start with our given, which is 64 grams of methane, and we're going to convert that to moles. So the molar mass of methane is going to be 16.00 grams per mole. And again, write in your complete units. So in this step, yes, we've converted grams to moles. Now we need to take the moles of the CH4 and we need to go to moles of the CO2. And we can see from our balanced equation, for every 1 mole of CH4, we're making 1 mole of CO2. So that's what we're doing next. And then our last step is, again, to take the moles and convert that to grams. So I'm going to use my periodic table. I'm going to use my molar mass sheet to see that there's 44 grams of carbon dioxide per mole. And as I do out the math, remember this is one big numerator, so I can do 64.00 times 1 times 1 times 44.00, and I'm going to divide by the product of this whole bottom, which is only 16, to get 176.0 grams of CO2. And when I look on the answer sheet, that looks correct. So you'll notice that I also put nice boxes around my final answer. That's going to be something that's going to be really important as we move forward. Many of you on the midterm, your answers were not marked clearly. It's really hard for us to find what we were looking for. So get in the habit of being clear with your work, spreading your work out, and indicating your final answer with a box. Hopefully this will be helpful. If you have any questions, make sure you ask them in class tomorrow.